We feel temperature pretty much every second of every day, right? But what if I told you that your own sense of hot and cold is, well, kind of wrong? You know that feeling of a cool breeze or a warm mug? Turns out it's more of a suggestion than a hard fact. Today, we're going to find out why and uncover the real story behind what we feel.
Do you have a fever? It's like the first question we always ask when someone's feeling under the weather. And what do? We instinctively reach out and touch their forehead, completely trusting our own hands to tell us the truth. But should we? And this is a perfect example of what I'm talking about. Fibon did exactly what we all do. She used her hand. It felt warm, so she figured her brother Lambok had a fever. But, luckily she didn't just stop there. It really makes you wonder, how reliable is that forehead test we've all been using our entire lives?
So let's actually dig into that exact point. Are our hands really reliable tools for measuring temperature? Or are they just super easily fooled? Okay, let's put this to the test with a really simple experiment that you can do at home right now. I promise this is going to completely change how you think about hot and cold. You ready? All right, step 1. You're going to need 3 bowls. In the first one, put some warm water. In the last one, get some ice-cold water. Now stick one hand in the warm and the other in the cold. Just keep them there for about a minute. Let your hands really get used to their new normal.
And now for the moment of truth. Take both hands out and plunge them at the exact same time into that middle bowl of regular room temperature tap water. Now remember, both hands are in the exact same water, feeling the exact same temperature. So what happens? Well, your brain gets totally confused. The hand that was in the warm water is now screaming, "Whoa, this is cold," while the hand from the ice water is shouting, "Ah, this feels warm." How can the same water be both hot and cold at the same time? It can't. It's a paradox, and it proves that our senses don't measure absolute temperature. They only measure the change in temperature.
And this really lands us on the core issue here. Our sense of touch isn't a thermometer at all. It's more like a comparison tool. It is simply not reliable for getting an objective measurement. It's all relative. So this leads us to a pretty logical problem, right? If our built-in system is this flawed, what can we trust to give us the real story? How do we get a measurement that's actually true for everyone, no matter if their hands were just in a bucket of ice? Okay, so since our hands clearly can't be trusted, we need a tool that isn't biased by what it just felt a minute ago. We need an objective standard. And you guessed it, that's where the thermometer comes in.
The answer is temperature. See, it's not a feeling. It's a hard number. It is a reliable, objective measure of how hot or cold something is. No confusion, no relativity, just data.
And the real hero of this story is the thermometer. Unlike our hands, it's not influenced by what it was doing before. It uses sensors to detect the actual energy of molecules. That's the true measure of heat. And it gives us a precise, objective number.
Now, of course, a great tool is only useful if you use it the right way. To get an accurate reading, it's really simple. Wash the tip, reset it, place it under your tongue, and just wait for that little beep. It's simple, it's hygienic, and most importantly, it's accurate.
And just a few key things to remember to protect our trusty tool. Always wash it, keep the display part dry, and always handle it by the body, never by that sensitive tip. This just makes sure the measurement you get is one you can actually rely on.
Okay, so we've got our reliable tool, and I'm pretty sure most of us have heard that magic number for a normal human body temperature. But what does that number actually represent? 37 degrees Celsius. We all know that number. It's like the universal benchmark for a healthy person. If you're at 37, you're good. If not, something's up, right?
Well, it's not quite that simple. Is that number an absolute, unbreakable rule? Or is normal just a little more complicated than we've been led to believe? So here's the key insight. 37 degrees isn't some magic number. It's the average temperature taken from a huge group of healthy people. Your personal normal might actually be slightly different, and it can even change throughout the day depending on your age and what you're doing.
All right, now that we've kind of decoded Celsius, let's talk about the other languages of heat, because temperature is universal, but we use a few different scales to talk about it around the world.
There are really 3 main players. You've got Celsius, which is the global standard for most things. Then there's Fahrenheit, which is still used daily in the United States. And finally, there's Kelvin, which is basically the language of science. It's the official unit for temperature in scientific work.
So that normal average body temperature we were just talking about? In Celsius, it's 37.0 degrees.
But in Fahrenheit, it's 98.6 degrees. It's the exact same amount of heat, just two totally different ways of saying it.
And, our tools are constantly evolving. We went from mercury to digital, and now to these non-contact infrared thermometers. These things were absolutely crucial during the pandemic, giving us a way to get that vital, accurate measurement safely from a distance.
And this all boils down to one crucial point. Accuracy is everything. The physicist Anna Mani said it best: wrong measurements are worse than no measurements at all. Just think about that for a second. A bad measurement doesn't just leave you in the dark, it actively leads you in the wrong direction.
And that leaves us with a final thought to chew on. We've just seen how incredibly easy it is to trick our basic perception of hot and cold. It really makes you wonder, if we can't even trust our own hands on something so fundamental, what other assumptions, what other feelings might be leading us astray? What else do we need a better tool to truly measure?